Okay, good morning class. Right there. Okay, so at this point we're looking at problems on rate. I think that's the last exercise in chapter 2 that we need to cover before we call this chapter to a close. Okay. So problems on rate. So here we are told this is examples for exercise 2.18. Examples for exercise 2.18. And this is on page 67. But this is example 1, and this example 1 is on page 66. Alright. So we're saying that Sepo, yes, is an experienced plasterer and working on his own. He can plaster a house in 4 days. Okay. Simon, however, does not have the same experience, and it will take him 7 days to plaster a house of the same size. The question says, how long will it take both of them if they work together on the same job? So in other words, if I look at the first person, I'm going to try his name again. Okay, I'm going to align the board quickly. Don't you guys have an old Apple computer there? Don't you, if one of your fathers want to donate one? Huh? Iman? Didn't you say you were going to try and ask for it? Is this one saying no? How much I? Okay. Yeah, better, no? For now. But this person will cover, how much of the job will he cover in 1 day? If it takes 4 days to cover a job, then that means to say 3-4 covers, or can do a quarter of the job in 1 day. Can you see? Simon, however, it takes him 7 days to complete the same job. So how much of the job can he complete in 1 day? 1/7. Huh? Not so? A seventh of the job he can the job in 1 day. So the question is, how long will it take them if they work together to complete the job? Can you see that? So in other words, if they're working together, so it's 1/4 plus 1/7, each one's part for the day, will then equal to 1. So if we let, sorry, I have to first start by saying, let x equal the number of days to complete job together. Okay, I have to first qualify where x is coming from. Okay, it's very rude if you bring your x to a conversation and nobody knows who he is. No? Not so? Alright. So that means to say, together they will complete 1/x in a day. People, what's my LCM here? LCM is 28x. Not so? Why are you laughing? Am I doing something wrong here? So why are you laughing? Why are you laughing? I'm feeling weird here. Alright. We'll be busy today. Come inside.
From Mr. Jackson for...
Who, Jackson?
Yeah, self-inscription.
Okay, no problem. Thank you. Okay. So 4 times what is 28x? 7x. 7 times what is 28x? 4x. X times what is 28x? So in other words, 7x times 1 is 7x plus 4x is equal to 28. You all agree with that? Now it's just a matter of solving for x. Not so. Which means to say that is simply going to give us 11x is equal to 28. So x is equal to 28 over 11. Or, if I convert that to days, 28 over 11. So they give us 2,55 days. Okay. You guys understand? So that's the first the first example dealing with rate. Okay. Let's look at the second example. Example 2. And example 2 is on page 67. Okay. Here we are told that 2 pumps are used to pump water from a river to fill a farm dam. Okay? So you've got 2 pumps, pump A and pump B. Ne? Or pump 1, let's call this pump 1 and pump 2. When operating together, they can fill the dam in 15 days. So importantly, together, they will fill the pump in, the dam in 15 days. So together, they will fill how much of the dam in 1 day? 1 over 15 in 1 day. You all agree with that? Because if it takes 15 days to fill the dam, in 1 day, it will cover a 15th of the dam. Or not cover, but full. Not so. Then we are told when operating together, okay, we got that. Working separately, 1 pump fills the dam 5 days faster than the other. So let's pump 1 be the slower pump. Okay? So we just put here slower. And let P1, which is the slower pump, equal x. So there's my x. So what would pump 2 be? The faster one. Remember, if it takes pump 1 10 days to fill the pump, okay? Then pump 2 is going to be less or more days? Less. Not so. Because it's going to fill quicker. Right. So here we are told, working separately, the pump filled the dam 5 days faster than the other pump. So pump 2, which is the faster one, in terms of x would be what? X minus 5. Not so. Now, in 1 day, how much of the dam will pump 1 fill on its own? 1 over x. In 1 day, how much of the dam would it fill if it works on its own for pump 2? 1 over x minus 5. Can you see that, people? It says if it works together. So what must I do? I must add the 2 together. Does it make sense? So we add those 2 together. Should give me an answer of 1 over 15. Sorry, man. You guys come with that laptop, no? It'll go better. Okay, so it's going to be 1 over x, pump 1, plus 1 over x minus 5, which is pump 2, is equal to 1 over 15. So what's my LCM here? My LCM, 15x into x minus 5. Okay. This gives us now. Oh, I'm hungry. Right, so what does it give us? This must times by 15 into x minus 5. So it's 15 into x minus 5 plus, what was the other one? The second fraction shorting? 15x times 1. And the third fraction is shorting the whole number. It's x into x minus 5. So the 15 is accounted for there. You all agree with that? So what do I do now? Solve for x. There's going to be 15x minus, what's 15 times 5? 65. Is that correct? 75. Okay. Thank you. At least somebody is taking note. Plus 15x is equal to x squared minus 5x. So 0 is equal to x squared minus 5x minus 30x is minus 35x. Not so? Plus 75. But of course now we're going to use the quadratic formula, not so? So we go quadratic formula, you can use the solver calculator as I have here. There's going to be 1 equals negative 35 equals 75 equals, so that will give me decimal 32,71. Otherwise, the other one would be 2,29. Okay. But now, what does this denote? This denotes the number of days, not so. This is days. Now, if the slower pump is taking 2.29 days, then the faster pump is going to take 2,29 minus 5, which is a negative value. Not so? So is it possible for it to be this one? No. So that one is out. So therefore, x is equal to, or the number of days it will take the slower pump, it will be 32,71 days, while the faster pump is 5 less than that. Okay? You guys understand? If you don't understand, you can watch the video again. If you don't understand after that, don't worry about the section. Okay? Because there's other sections where the sums or the marks will almost be definite. Whereas this year, it could be any one of it, either 2.1 of 2.17 or 2.18, or at times none of it. Okay? Whereas the other exercises are more examined than these sections. Okay? Otherwise, in the description box below, you'll find the exercise 2.18, each and every sum of those 4 sums are explained in that exercise. Okay? So that brings chapter 2 to a close.